Alright, so we start out and we look for the low-hanging fruit. First thing you do is check change control. If someone's put a change control entry in and they're changing the specific thing that you're having the problem with, it makes sense for you to check change control to see, well, if something changed and it's like WebSphere and suddenly WebSphere's not working, maybe we should go and look at what that change was. Another thing is to look in the error report. And I know this sounds like common sense, but I can't tell you how many times I've been looking at a problem. I've looked at the error report and it's like, well, you think you've got an I/O error. Pretty sure you have because you've got some permanent disk errors. So check for paging. Check your system to see are you using 100%. If you're in the shared pool, are you constantly over entitlement? Or if you look in Nmon, there's a tab that shows you if you're folding and unfolding VP. Is the ratio of system more than user? Basically, if you look at a VMSTAT, in the shared processor pool, user and system aren't as useful as they used to be with dedicated. But what you can look at is, if I've got 20% of whatever I'm using is user and 60% of it is system, that tells me that the system and the kernel are really busy doing stuff on behalf of my application, and my application's not doing much. You really want to see user time much higher than system. Is there unexplained I/O weight? And I'm going to talk about I/O weight because there's a lot of confusion about what that really means. You know, look at your SMT threads. Are they being used evenly? Are you only using the primary thread across all your virtual processors? Because if you're only using the primary thread across all your virtual processors, you've got too many virtual processors. All right, you're not spinning up those secondary and tertiary threads. Looking at your I/O, how's it spread? What's it look like on the adapters? Full file systems, you know, var, slash, or user, if they fill up, your system's going to go down. So you want to pay attention to those, and if you see them filling up, go find out who's writing to them. And as an example, I don't allow logging to go to /var. I actually set up all my logging to go to user local logs, which is its own file system. Because I've had logging fill up var when things went crazy, and the system went down. But if I put it in a file system like user local logs, and user local logs fills up, I just stop logging. And by default, AIX doesn't do a lot of logging. You have to go tailor it anyway. You can also go to Fix Central, see if it's a known bug, the same with the firmware history. And then I have the link here to reporting a performance problem. IBM requires that you use perf PMR. So when you're reporting a problem, you really need to make sure you understand how to use perf PMR, which is why I suggest you use it as part of your baseline. And you need to make sure that you download the latest version. So whenever you go to take a baseline, just go over to the perf PMR site, make sure you have the latest for the version that you're running, and run it. It just should be part of your toolkit. What kind of things slow the system down? Well, there's some obvious things. You don't have enough CPU or entitlement or VPs. You don't have enough memory, not enough disk I/O or network. But there's a lot of not so obvious things. There's AIX tuning, making sure that your system is actually set up correctly. There's for Oracle and DB2, the placement of your logs, your SGAs, your buffers, all those kind of things. Is your workload 100% write versus 100% read? That's very different tuning characteristics. Throttling effects, and I mentioned this up front, that if you have what we call a gating factor, so everything that wants to run, whether it's multiple threads or not, if it has to get permission from one thread to run, then you have a single thread dependency. I left Java off this list because that's pretty much a guarantee. There is a new Java advisor. IBM brought out 3 advisors, the VIO server advisor, the Java advisor, and a virtualization advisor. So where you have Java workloads running, and I don't have it on this presentation, but you may want to run the Java advisor and see what recommendations it makes for your Java heap and so on, because Java can be a significant application that basically slows your system down. There could be background processes. I find it all the time where somebody kicks off a backup out of cron right during peak online time, or maybe some log processing or something like that. There's a lot of things that can make it go slow. So at the beginning we talked about the whole speed versus distance and throughput. In terms of what we're measuring, if we're looking for response time, we're really talking about the end-to-end time where I hit enter. So I do a database query, or I type something in and I'm waiting for something to come back, or accessing a web page. It's really about user perception of how long they're waiting for things, versus throughput, which is how much can I put through in a minute. The difference, if you think about it, response is how long did an individual query take, and throughput is about how many of those queries can I do a minute. So we have to figure out which one of those we're measuring. I put this in because it's a sort of an entertaining version of a performance support flowchart. I hassle my husband because if I'm not around and he has a problem on his PC, he pretty much goes to start and then follows this option 1 here, where he just starts clicking on things till something happens. This is not actually how you would really look at a performance problem. There's actually a better one on the next page, which is far more accurate. And you may not use it this way, but what you want to have is a strategy for how you deal with a performance problem. Yes, I've got a performance problem, so I'm going to follow the flowchart. I'm going to go, okay, am I sharing resources? Take this action. Am I CPU bound? Do this. Am I memory bound? So basically, whatever order you do it in, you might want to look at paging first, or you might want to look at something else until you get to the point where performance gets back to what it's supposed to be. And that's a really important thing that a point that I want to make related to this is performance tuning and performance problem analysis is an iterative process. No matter what anybody tells you, you are not going to get it right first time. It takes time to get this right. And so you may have to make 2, 3, 4, 5 changes. Now, for the most part, they're going to take, sometimes they'll take 2 minutes, sometimes they'll take a couple of hours, sometimes they'll take a few days. But, don't assume that there's going to be a quick fix. There's probably going to be multiple things you'll have to try, and how good change control is in the documentation and so on. So having a flowchart like this that you follow, that is a good thing to do. We talked about monitoring CPU when I was talking about the percent user, percent system. So when I'm looking at actual utilization, I'm looking at physical cores consumed when I'm in the shared processor pool. And I'm looking at that ratio between entitlement and VP. When I'm looking for, do I have a problem where the system is doing more than it should be and the user's not getting any work done, I'll look at the ratio between user and system time. So that's where I'm going to use those VMSTAT inputs and so on. I have here just some terms that it's good to understand. So when we talk about processes, we talk about an activity that started with a command or shell script or another process. Now in AIX, they use the term process and thread interchangeably, but a thread is typically what is going to get dispatched. So something that's important to understand is the concept of a run queue. Every logical CPU has a dedicated run queue, and it's basically a list of the threads, and they're sorted by priority. So when I get dispatched to the run queue for a logical CPU, and then if I give up the core for some reason, whether it's voluntary or involuntary, when I get dispatched again, it will try to dispatch me on the same run queue. If I can't get serviced quickly enough, it'll put me onto the global run queue and I'll get dispatched somewhere else. And of course, new threads come in, they go to the global run queue, and then it chooses a CPU run queue to put them on once it figures out where it's going to put them. And then the time slice, you heard me talk about the 10 milliseconds before, that's basically the dispatch window. So if you get a whole CPU clock cycle, you get 10 milliseconds. But if you get 0.5, because that's your entitlement, you get 5 milliseconds. And then how that 5 milliseconds is spread depends on how you have virtual processors set. So for instance, if you have 2 virtual processors and a 0.5 of a core entitlement, that means that you really have each virtual processor worth 2.5 milliseconds. Interestingly enough, since I could get 10 milliseconds on a core, those 2 virtual processors could get dispatched to the same core one after the other. Or they could get dispatched to 2 different cores. It just depends on what's happening at the time. So this is an example of the *P all, which shows you all the SMT threads. And I'm using this simple example here for SMT2 to show you a couple of things. The first thing is I have an entitlement of 0.8. And if you look down here, this is the average, this is the total line. It's showing me that I'm using 0.8 and I'm using 100% of my entitlement. Now this is an SMT2 example, so you can see from my FIZ-C that my pairs of logical CPUs, each of them sums up to half the entitlement, which is what I would expect because I have 2 VPs. This is the first VP, this is the second VP, and under each one I have 2 logical CPUs. And the MPStat-S down the bottom here is showing the same thing. So this here, proc0 is a VP, and then these are logical CPUs down here. That's the SMT2 example. For SMT4, the example I have, unfortunately the system wasn't busy, so you'll see there's a whole bunch of these missing, like 4 through 6 are missing here, and that's because they were all zeros, so it just doesn't print them. And this is showing you that I have unutilized, I have this not 0.98 of a core, even though I have an entitlement of 1. On average, my total here down here is I'm using 0.02. So it's not a good example in terms of having workload, but that's why I used the one from SMT2 before. But it gives you an idea of what it would look like. There's actually a new version of this that I prefer, which has the *-mu, and that's all lowercase except for the capital P all. So what I wanted to show you in this example is that down here for my average, you can see that I have an entitlement of 7. So this is SMT4, so this would be like proc 0, proc 4, and so on. But when I do this total down the bottom, I'm actually using 12.9 cores on average, and I'm at 184% of my entitlement. If this was an average over a long enough period of time, then I would want to consider increasing my entitlement, because if I'm spending 200%, if I need 200% of the entitlement, then that's what I should be set to. Because what I don't want to have happen is that I'm constantly going back to the hypervisor saying, give me more CPU, give me more CPU. I only want to be doing that when I've got true peaks. And this is an example which would be really bad of a VIO server going through the same thing. So this VIO server, on average, is using 1.74 cores and 158% of its entitlement. I would probably bump this to an entitlement of 2, because I want to make sure I never ever want to starve my virtual I/O servers. If you starve your virtual I/O servers, none of your LPARs are going to run well. The thing that you'll also see here, which is kind of indicative of this problem, is look at my system. The bulk of the time, the work that's going on is the system doing work on my behalf, which there's no applications running in here, so that would make sense. But that seems a little on the high side to me, and I think it's because we're doing a lot of time asking for more resources. So don't do this to your VIO servers. So I have a VMSTAT example here, and this is using the VMSTAT-I, showing you pretty much the same thing here. I have an entitlement of 7, and when I go down here, you can see my FIZ-Cs and my entitled cores. So again, I'm over capacity here, but I just wanted to show you that so that you would see it. Just be aware that that's something that there's multiple places you can find the same thing.